All right, we came to the last problem, but it's also a challenging one, and it's been since the very beginning of the year since we've seen this problem. So we're going to do a little review. This video may take a little bit longer than some of the others. Which equation below is false? We learned about 5 or 6 properties of exponents way back in September, and that's what we're testing. One of the first properties we learned is that if we're multiplying with the same base, we keep the base and we add the exponents. And we may have said that as x to the a times x to the b equals x to the a plus b. And that's what we're seeing here. Multiplying with the same base, keep the base, add the exponents. That is a true statement. Letter A is true. That's not the one we're looking for. We're looking for the false statement. And then we have this one right here of 2 to the 14th divided by 2 to the 20th equals 1 over 2 to the 16th. Our property for dividing is if we're dividing with the same base, x to the a divided by x to the b, we subtract those exponents, x to the a minus b. So that's actually true here, that we could rewrite this as 2 to the 14 minus 20, which is negative 6. And that brings us to a whole nother property that tells us that if we have a variable to a negative exponent, it's the reciprocal of the base to the positive exponent. That we cross the line and change the sign is one of the things we talked about maybe, or we take that exponent to the denominator and make it a positive exponent, but that 2 to the negative 6 is equal to 1 over 2 to the 6. This is also a true statement. Now, one thing that we may have said to simplify this, if that gets a little confusing to you, is when we look at this one, there's 14 2's on top. There's 20 2's on bottom. Where are there more 2's at, top or bottom? Bottom, right? So that's where my base is going to go. And how many more 2's are on the bottom? Well, if there's 14 up here, and 20 down here, there's 2 to the 6th on the bottom, and that 1 is my numerator. But regardless, that's a true statement. We're looking for the false statement. We also learned way back in September a lot of properties of exponents, that if we're taking a power to another power, we multiply the exponents. So x to the a raised to the b is x to the a times b. True statement here. 4 times 5 is 20, so 2 to the 4th to the 5th, 2 to the 20th power. All three of those is true. This is your false statement, and we can look back up here and recognize it with our property of negative exponent. That doesn't make my base negative. If I'm applying my property of negative exponents here, that 2 to the negative third is equal to 1 over 2 to the positive third. A negative exponent means we take it to the other part of the fraction and change the sign. So in this case, the sign of the exponent, by the way. So this case, we take our 2 to the denominator with positive 3 as its exponent. So reciprocal of the base to the positive exponent. This is your false statement. The correct answer for that would be 1 over 2 to the third.